Hello students, good morning to all of you. So today I am going to explain motion in three dimensions and how to calculate the velocity and calculate the acceleration of a particle in three dimensions using the vector method. As we studied about the motion in two dimension, in that motion the particle is being restricted to move in two dimensions. उसे two dimension में ही restrict है उसका motion and but this type of thing is not in the three dimensional motion. तीन dimensional motion में या three dimensional motion में particle जो है it is not being restricted to move in a plane. Okay, so थ्री डायमेंशनल मोशन को रिप्रेजेंट करने के लिए, उसके बारे में बताने के लिए, पार्टिकल की पोजीशन को लोकेट करने के लिए वी नीड थ्री पोजीशन कोऑर्डिनेट्स. सो फॉर दैट वी नीड थ्री म्यूचुअली परपेंडिकुलर एक्सिस. Generally we take x, y, z are the three mutually perpendicular axes, and to locate the position of a particle in three dimension or in space we need three position coordinates. So on that basis we first derive its position vector, and then the differentiation of position vector with respect to time we get the velocity. तो इसके बारे में हम अभी ड्राइव करेंगे इसे और समझने की कोशिश करेंगे. So first of all we need three axes, like this is our x axis and this is our y axis and this is z axis. So all three are perpendicular to each other. तीनों एक दूसरे के साथ म्यूचुअली परपेंडिकुलर है. म्यूचुअली परपेंडिकुलर मीन्स सभी एक दूसरे के साथ परपेंडिकुलर यहाँ पर है. And let us consider that we have a particle and it is at this point. इसका नाम हम रखते हैं P. Okay, so there is a vector that join this particle from the origin. We always choose origin because we need some reference point to with respect to that we tell about the various things. So we definitely need a reference. So that is our origin here, O point. So particle is at point P and it is in three dimension, it is in space, so it must have three position coordinates, x, y and z. Let us consider that these are the coordinates, position coordinates of this particle which is located at point P. So this is a vector that is known as the position vector and we represent it by r vector. पोजीशन वेक्टर वो वेक्टर है जो आपके पार्टिकल की पोजीशन बताएगा, आपको उसका ये डायरेक्शन बताएगा कि किस डायरेक्शन में आपका पार्टिकल विद रिस्पेक्ट टू द ओरिजिन present है. So this vector leads us towards the point P. Okay, and in the vector form we always need some vectors to denote the direction and we take them or we know them as unit vectors. So for x direction we take vector I cap. I cap means unit vector I, which is in the x direction used for x, and similarly j cap for y direction and k cap for z direction. Okay, ये unit vectors हैं, these are used to give the direction. And now if I have to write the position vector for this particle, so position vector है इसका r vector is equal to x I cap plus y j cap plus z k cap. This is the position vector, or this tells us about the position of a particle in space or in three dimensions, and these x, y, z are the coordinates and I, j, k are the respective directions. Okay, किस किस डायरेक्शन के लिए क्या क्या हम वेक्टर का यूज कर रहे हैं. तो इस तरह से हमने इसका r वेक्टर लिखा, and in three dimension our aim is to calculate the velocity of the particle. तो पार्टिकल की velocity निकालने के लिए हम जानते हैं velocity is change in position with respect to some time, and we differentiate that position vector with respect to time and we get the expression for velocity. So ये कुछ इस तरह से आएगा, like dr by dt, it gives us the velocity. So we differentiate this d by dt x I cap plus y j cap plus z k cap. Okay, so ये हमें velocity मिल रहा है, total velocity मिल रहा है, net velocity. So it is very simple, and हम इंडिविजुअली करेंगे अब dx I cap dt plus dy j cap upon dt plus dz k cap upon dt, and यहाँ से हम velocity in different direction लिख सकते हैं. So dx upon dt is like vx, तो इसे लिखेंगे हम vx with the direction I cap plus Vy j cap plus Vz k cap. This is the velocity in the vector form, and if I have to calculate the magnitude of this velocity, so now this is the expression for the magnitude: Vx square plus Vy square plus Vz square. So this is the magnitude of the velocity, and this is basically the velocity in vector form for a particle that is in three-dimensional motion. Next, we have to derive the expression for acceleration of this particle. How we derive that acceleration expression? As we already have the expression for velocity, Vx I cap plus Vy j cap plus Vz k cap. So what is acceleration? Acceleration is the rate of change of velocity, so it is like dv upon dt. So it is coming like dvx upon dt I cap plus dvy j cap dt and dvz dt k cap. Okay, और हमें यहाँ मिल रहा है acceleration. So this is very easy, I think, and you use these expressions to calculate the acceleration, velocity or the position of a particle in three dimensions. First of all, हमने सबसे पहले position vector लिया था, and then differentiate that position vector with time and get the velocity. And again differentiation, we get the acceleration. So it is coming like ax I cap. This is differentiation, means x component of acceleration, and this is like y j cap and az k cap. This is a vector quantity, and it gives that this is the acceleration in the x direction, this is the component of acceleration in the y direction, this is the component of acceleration in the z direction. So because this is a three-dimensional motion, and if you want the magnitude of this, it is like ax square and ay square plus az square. You get the acceleration in magnitude form. So this is quite easy to solve this type of expression. So at last, I just want to say, in a three-dimensional motion, you need three coordinates to specify a particle, its position, and after that you can derive its velocity as well as acceleration. In 2D, the particle is being restricted to move in a plane, and most of that is we need two coordinates to specify its position. Like this board is in the two-dimension. This is a plane. So in three dimension, you need three coordinates, and particle is being free to move, and it is in space, so there is no any restriction like the restriction in plane. So I hope आपको derivation of acceleration and velocity समझ आया होगा. With that, thank you very much.